Now remember, give me your transformation. Start with your regular graph. We have a regular graph of a log base 10. It's got a domain from 0 to infinity. It's got a range from negative infinity to positive infinity. An x equals 0, and it has a 1, 0, x-intercept. When you do the negative x, just make your finger go from positive x to negative x. Do the slide across here. When the negative is next to the x, it's the x that's negating. So your reflection is over your y-axis. The easiest way to remember it. Because when kids see negative x, they say x-axis. But the negative x is reflecting over the y-axis. And the only thing that's going to change is, well, there's two things. Your asymptote will stay the same because it reflected over that axis. Your range will stay the same. Your domain just changes. It goes now from negative infinity to 0. And make sure you write it in the right order. You can't write 0 to negative infinity. You have to be able to read it left to right. And the intercept reflects as well. That just becomes the negative 1, 0. Solving your intercept algebraically, when y is 0, flip it to an exponential equation. 10 to the 0, which is 1, is equal to negative x. Divide through by a negative 1, so therefore there's your intercept at the 1, 0. I want you to do this without your calculator. Confirm it on your calculator. If you can't figure out what one step does, put that one step in your calculator. But make the rest so that you can follow the domain change. Follow the range. Well, the range is not going to change. Follow the asymptote. I want you to see what each thing does to those parts. And then put the whole thing together. Stop me if you have any questions. The ln's work the same as a log. It's a log base about 2.7, which is probably close to the behaving like a 3. It behaves between a 2 and a 3. And all that it does as we increase it is just get closer to the axis. All our sketches look the same because you're still doing the same movement. You've got your basic one. Again, start with your domain. Oops. Start your range, your asymptote, and your intercept. Okay. When you take a horizontal shift, it's the opposite direction, so everything has to shift 1 over. So your domain shifts 1 over, and your asymptote shifts 1 over, and your point where you cross the x-axis will shift 1 over. When you do this out, guys, algebraically, when you set this equal to 0, when log equals exponent, what's the base of a natural log? E. So it's easier to put the base in here to see it. Same thing when we do base 10. If we do this is the time that you put the base 10 in here. So you say 10 to the 0. This time you say e to the 0. There's your exponent. Equals x plus 1. This is a 1. Anything to the 0 will be 1. We subtract 1, and x is equal to 0. Make sure you can solve it algebraically. I don't need you to do the y, just the x, because that's what we concentrate on, your x-intercept that changes. And this is a good exercise in doing different bases, putting the different bases in. Can you all put the other bases in your calculator, even if you have to make a divide? Not all of them have the ability to change a base. Okay? Turn this around. Do your negative x plus 3. So you're going to go do your left 3 and a horizontal shift left and then a reflection in the y. Start with your domain and your range again. Anything that changes horizontally is going to cause you to shift your domain. Your asymptote moves with your domain. And your intercept, again, make sure you use a base E to find it. I know you could count those spaces over, but you're going to have to show me algebraically. In this case, it's shifting left first, and then it's reflecting. If you reflect first, I don't think it would work with if you reflect first, yeah, then you'll shift back the other way. You'll just have to reverse your shift, depending on which way you went with it. Okay. This one is just a regular base 2. I think I just forgot the rest of the transformation here. I was going to do a vertical shift on this. So let's do a vertical shift on this. So say we do +3. We didn't have any vertical shifts here. If I do a vertical shift of +3, where is this going? Up 3 units. So I'm going to go up 3 units, and we need to take your hat. Up 3 units. You use this point to help you move up. So now you're at the 1, 3. It's still going to work the same way. Did I change my asymptote? No. Did I change my domain? No. There's no horizontal. If it's just vertical movement, the domain stays the same. And the asymptote stays the same. The one thing that will change is your intercept. And you're not really going to be able to count it over here. You're going to have to work this out. 2 to the 0. Oh, let's change this. Move the 3 over first. And then log equals exponents. Base 2 to the -3 equals x. So this is equal to, remember the negative takes the reciprocal. There's your 1/8. And then I'm going to add the 3 back. Oops, wait. X is equal to 1/8. That's it. So here's your intercept. Very, very close to the 0. It's going to ride along the axis. What is this for? Yeah. To find where this point is right here. Oh. We can't find it otherwise. The other ones we were able to count when you're moving it over and they give you nice numbers. This one you can't. So, and you have to solve them algebraically. To find your x-intercept, you set y equal to 0. And we get our 1/8. Okay. Good. One more. This one was a good one in using your power rule. Take your power rule and bring it down. And it works like any of your other ones with your parabolas. If you did this, and I did y equals 1/2 x squared, that's your vertical shrink. And so what it does is it changes the distance from 0. It makes it closer to the axis. So what this is going to do is just make this a little bit closer to the axis. And again, the calculators have a hard time showing this. They show your regular one like this. They show the other one even worse. It starts just a little higher and it looks like that. So it looks like it's ending, but it's not. It's just getting a little bit closer to 0. This is a vertical shrink by a factor of 1/2. It doesn't change your domain. It doesn't change your range or your asymptote, but it does change your intercept. It doesn't change your intercept either on this one. So you're okay with this. Good? Can everybody do these without the use of your calculator? Yes. I think it's so much easier without your calculator because you can see each thing step by step. And I think in the beginning we were doing them too quickly.